So your test is going to have some multiple choice. There's going to be a lot of conceptual stuff, really a lot of stuff about Newton's first and Newton's third. You don't need to know which one's which. You just need to know that forces come in. Okay, you don't need to know that's Newton's third. You just need to know that's a Newton's law. And you need to know that, well, Newton's first says this: unbalanced forces must make an object. What word goes in there? If the forces are not balanced, what must this object be doing? Has to be accelerating. And the flip side, if the object isn't accelerating, then the forces must be, I'm looking for a word that starts with letter B, balanced. And what we're really now going to start to say is that actually gives you an equation. If forces are balanced, it's a tie. Left side equals right side, or everything down equals everything. When I'm doing my, is it sinking to the ground like quicksand? Is it flying like Superman speech? What I'm really saying is everything down is going to equal everything up. And if it's just gravity and the normal force, that's easy. If there's extra vertical forces, and I'll do one like that, you'll have to set up a little mini equation. Newton's second law, F net equals what? Okay, there is on the written section going to be, I think it's the first question, I'm going to use the phrase F net. If I say F net, do you need to do a free body diagram? Nope. You can go straight to F net equals MA. And how many variables are there in this equation, technically? 3. I'll give you 2, find the third. So either I'll give you the mass and the acceleration and you can find F net, or probably more likely I'll give you F net and either M or A. How would I get the M by itself? Divide by A, and that's if you ever want to take a force and convert it to its equivalent lifting mass in kilograms, divide by the accelerate, or divide by 9.8 as our gravity acceleration, okay? Newton's third law, forces come in pairs. Technically, opposite pairs, but I think you all get that. We use Newton's third to figure out what the force was. We used Newton's first to figure out we were missing a force, or had to add a force. We usually use Newton's third to figure out, okay, what is that force? Oh, it's the opposing tension to this tension, or whatever, okay? You'll need to know, and this is probably, again, a good conceptual question, the difference between mass and weight. Mass is measured in units. Yep. Weight is measured in, okay? How do you calculate weight? It's on your green sheet, but it's kind of nice if you have this one in your brain. When you look at your, I was going to say, when you look at your green sheet, you're going to go, oh yeah, so. Yeah, it's the obvious one. I might give you a multiple choice question where you're on the moon and G is, I'll tell you G 1.6. You do need to know that, no, you don't need to know that G on the Earth is 9.8. It's on your sheet, I think, as a matter of fact. But you don't need to memorize that G on the moon or on Jupiter or something. I'll give you that. But certainly as a good conceptual question, which one doesn't change anywhere in the universe, mass or weight? Okay, so if you go to the moon, does your mass change? What does change? Your weight. Your mg. Why? Because g changed. Okay? Oh, here's a good multiple choice question. An object with a mass 55 kilograms is on the moon. Which of these statements is correct? A, the object has a weight of 55 kilograms. The object has a mass of 88 newtons. The object has a weight of 544.5 newtons. Or the object has a weight of 88 newtons. Which of those can you reject right away as this must be wrong because you don't work for Verizon? Weight is not measured in kilograms, right? Oh, and mass is not measured in newtons. So I would cross those two out right away. Which one of those is correct? This is where you might want to get your calculator out. Sorry? How would you figure that out? You would go mg, but since we're on the moon, you would use g from the moon. So you would go 55 times 1.6, and it turns out to be d. Okay, so that might be a nice little multiple choicey question. Free body diagrams. You've practiced drawing them a bunch. There will be one question on the test where I actually give you some space, very similar to your take-home quiz, where I say, look, draw the free body diagram. Show me you can draw this free body diagram. And I'll just give you marks for that. I'll even be more blatant. Probably it will be worth 2 marks, which probably means there's going to be 4 arrows, probably a half mark for each arrow. If it's 1 mark, it probably means 2 arrows or something like that. Anyways, unless I say net force, you can go straight to F net equals MA. Otherwise, what has been our template? What minus what equals? And we've even said you can replace the F net with MA. We've gone winner minus loser. Let me make that a capital L because that looks too much like a 1. I notice these things. And so what I'm really saying is actually, okay, we're going to do the same as we did in the last unit. Let one way be positive, one way be negative. But in the last unit, up was always positive, down was always negative. Here, we'll let positive be what makes the math nicer. And so sometimes down is positive because it makes the math nicer. So now let's do some actual questions. This says find the acceleration, but there's no numbers on here. So I'm going to say m equals 12 kilograms. There's a downwards force here. Someone's pushing down with 15 newtons. They're pulling with, I want to make sure this is going to move. Hang on, let me just pause for a second. So let's make, by the way, what do we call this mystery force coming from off the page? We gave it a label. What do we often call it? This was technically F applied, something from off the page, right? So F applied. I'm doing some quick math in my head. I want to make sure that this will accelerate. Let's say F applied was 85 newtons. And let's put some friction in. Let's say there's a coefficient of friction of 0.31. Okay, find the acceleration. This is already a pretty challenging question. Can you tell me what makes this question tougher than normal? Can you see it? Yeah, the 15. Normal force is not mg. Okay, I can't just go, oh, but look. I'm going to have to do some thinking here. But this is still a job for a... Did they give me a picture? I'm going to label the picture. So, Jaden, what are the forces acting on this 12? Get the obvious one. Is it sinking into the ground like quicksand? Is it flying like Superman? Normal force normally would be the same size as mg, but is there an extra vertical force? So here's the question, folks. Is the normal force bigger or smaller than mg? Not the same size because there's extra vertical force. Normal force bigger or smaller than mg? Why bigger? Pushing down, the ground has to push back harder. Okay? I'll exaggerate it. Yep. What else? I would do that last, but what else? I always put an arrow on this so I don't forget it because it happens. And yes, friction. Okay. I think friction's probably losing, I hope. So who's winning? I think F applied. I was trying to do the math in my head. It's possible friction might be slowing this object down. We'll find out, but I think I'm okay. So what equation would I write here in my winner minus loser routine? What minus what equals what? I'll do it algebraically first. I'm going to go F applied minus friction equals MA. If you get to this line, now as far as I'm concerned, the other thing I could have done is I could have told you I could have told you the acceleration and had you find F applied. Get that by itself, plus friction over. Or, because there's a mu hidden inside here, I could have had you get the mu by itself. I think I have one later on. If I don't, remind me, and I'll do one with you folks later on. But for now, we can use Alex's theorem. Ta-da. I'm going to try and keep this all on one screen. So normally I'd work down, but I'll work sideways. A is going to be F applied 85 minus mu times the normal force all over m. I don't know the normal force, and it's not mg. Somewhere in the margin, or since I have space, I'm going to do it right here. I would now write a vertical equation. Are we sinking into the ground like quicksand? Are we flying to like Superman? That means everything down has to equal everything. What's that equation? What is everything down? There's two things. There's two things pointing down, right? Two arrows. It's going to be mg and that 15. Oh, and means plus, yes. What's everything pointing up? Only one arrow. the normal force. So conveniently, the normal force is already by itself. It's mg plus 15. You could crunch that if you want to, or if you kept going, it would look like this. 85 minus mu, and then in brackets, mg plus 15, because that's the whole normal force. So you could either turn that into a number and stick it there, or if, like me, you like to do things in one step, you could put the algebraic expression there, but you would have to put it in brackets because it's mu times this whole thing. A common mistake I saw people doing on their calculator was this. Well, now you're only multiplying the mg by the coefficient of friction, by the mu. You need to multiply the whole normal force by the mu. The brackets there, all over m. And now I think I'm good to go. I can go 85 minus what's mu? I don't know what's mu with you. 0.31. 12 times 9.8 plus 15. All over 12. Everybody try typing this in. This is good calculator practice. And there is going to be one like this on your test where the normal force is not mg. There's either going to be something pushing down or pushing up. Bracket 85 minus 0.31, another bracket. 12 times 9.8 plus 15. Close off the mini bracket, close off the top, divided by 12. I hope I get a positive answer. Hey, we are accelerating. Did you get 3.66? Units, it's an acceleration. Okay. Jaden, did you get that okay? Yep. Good. Okay. So there's going to be one block sliding across friction, applied force, and a weird normal force question. Find the coefficient of friction if this object is accelerating to the right at 2.5 meters per second squared. So here's what I said. If you can get to this line here, as far as I'm concerned, you can get anything you need to by itself. So how would we do this one? What might this be a good job for? Yep. Although they gave me a picture, let's label the picture. What are the forces acting on it? Yep. What else? Bigger, smaller, or the same size as mg? Yeah, okay. Oh, but look. Yeah, same size. What else? We have F applied and friction. What does this question want me to find? It wants me to find that. What has that hidden in it? I think I'm going to get this by itself, and then once I get that by itself, then I'll try and get the mu by itself. Got the argument? So who's winning? To the right. They told me. I could have to the left. That would just mean it's slowing down, and friction would be the winner. Okay, but to the right. So my equation is going to look like this. F applied minus friction equals ma. What am I trying to find? The coefficient of friction, which is hidden inside here. Let's get this by itself. What's right in front of friction that I don't like? Swappy dance. Plus the friction there, minus the ma there. And I'll get F applied minus ma equals friction. Now what? Friction is what times what? So F applied minus ma equals mu Fn. How would I get the Fn? No, how would I get the mu by itself? I don't know Fn. Oh, but look. I don't know the force the same size as the normal force. mg. So mu is going to be 50 minus 10 times 2.5 all over 10 times 9.8. Now you want to type on your calculator. Top in brackets, yes. Bottom in brackets, yes. Do you get 0.255? 2.255? What are the units for a coefficient of friction? No, that's convenient. Okay. What if A was 0? And your equation would just end up being F applied equals friction, because no MA. It's a tie. I think that's about all the... Could slow down, friction will be winning. Could be 0, it's a tie. Accelerating, F applied is winning. If A was 0, because then you know it's a tie. Okay? So if it said constant velocity or constant speed, you would say, you could still start out here, but if A is 0, what's m times 0? Still. So when you move it there, you'd have a 0 right there. Well, that's not, you're going to end up, sorry, I erased too much, more than I wanted to. You'd have a 0 right there, and you'd end up with F applied equals friction. Is that all right? Nope. Erased too much. So there's probably going to be a question where I ask you to find a mu somewhere, I'm pretty sure, a coefficient of friction. Rocket ship. This is on some of my tests. I can't remember if it's going to be on yours or not, but rocket science. So a rocket which weighs, is that the mass? How do you know? First of all, I think I can make this, can I make this larger, Mr. Dewick? Let's make the font a bit bigger so that Camille can read it in the back. A little better. Why can't that be the mass? Newtons. Okay. So here I told you to find the mass. I think I would be comfortable on a test not giving you that hint, jumping straight to part B or part C. But to find, how do I find the mass? Divide what? Which newtons? There's 2 of them. There's 50,650 divided by 9.8. It's going to stay on my answer button. I'll write 5168, but I'll try and keep this on my answer button. Okay. B, the upward acceleration. Is there more than one force in this question? How do you know? I see 2 numbers with newtons next to them. So you know what this is a good job for? Here's your rocket. What are the forces acting on it? Get the obvious one. Acceleration isn't a force. I got to be fussy. I gave it a name. You could call it that. I wouldn't take marks off, but I actually used a fancy schmancy word in the question. Force of, I'd probably call it F prop. Bigger, smaller, or the same size as mg? Well, mg is 50,000. F prop is 63,000. Hey, Captain Obvious, it's bigger. I know the numbers this time. What's my equation? Equals. So as far as I'm concerned, for the rocket setup, I can either give you both of these and say find the acceleration, or I could tell you what I need the rocket to accelerate at. How strong does the thrust have, the propulsion have to be? Plus the mg over, right? In this case, they want me to find the acceleration, so divide by m. A is going to be 63,400 minus 50,650, and you'll notice I don't need to multiply them by 9.8. These are all in newtons already. I'm happy with that. Divided by, I'm going to write 5168, but you know I'm using my answer button. Bracket 63400 minus 50650, close bracket, divided by answer button. Check for typos because there's a one-shot 63400. Looks good. And I get an acceleration of 2.47. Okay. What's C asking us to find? Which one? Yeah. What's VI for a rocket? I've watched them. I haven't seen any rocket take a running start or something. No, yeah, they start at rest. Okay. So without deficking, can we go to the equation? Which equation could I use here? Even easier, I think. What? Don't waste my time. Couldn't I just go VF equals AT? Because VI is 0, right? We've come a long way. Remember how awkward that was a month and a half ago. Now it's almost eye-rolling. Oh, okay. So, VF equals AT. So it's going to be my answer button times 65. If you write A and S in your note, like in your work on a test, I'll clue in what you mean. I don't know if they'll let you get away with that in post-secondary, but I'm pretty easygoing. So 160 meters per second. That's about what? Half the speed of sound? There's going to be a whole page on elevator questions. In fact, I'll even be more specific. There's probably going to be unos, dos, tres, cuatro, 4 of them. I'll bet you in one of them you're going to be accelerating up. Another one you'll be accelerating down. Another one constant velocity. And another one in free fall. Okay? If you're at a constant velocity, does it matter which way you're moving? Newton's laws don't care and don't tell us movement. They tell us acceleration. We usually ask about a scale reading. What force are we really talking about when I say, tell me what the scale reads in an elevator? Yeah. Right? So make sure you have an FN clue, was the dumb joke that I think I brought out with the concept of normal force. Good conceptual questions would be things like, okay, if the elevator is accelerating up, this would be multiple choice. The person feels A, heavier, B, lighter, C, the same, D, need more information or need to know their mass first or something like that. Accelerating up, what do you feel? Has your mass changed? What's changed? Which force? Which force changes? Yeah. What all of you think of as your weight, it's actually you're detecting your own normal force. Just for the record. Just a habit that you have. So, heavier. So, example 2. Let's make this font a little larger so that all you rebels sitting in the back can see it better. Can you read that okay, Camille? Is that big enough now? Okay. What's the scale reading if the elevator has it? Oh, this is a job for a free body diagram. Let me see, Mr. Duick. Nope, I was going to see if I had room on the side here. I really don't. I'll do them over here. So here's my free body diagram. What are the forces acting on this person? What else? Bigger, smaller, or the same size mg, and how do I know? Why? Got to be fussy. Not going down. Thank you. So I would have noticed that ahead of time, and so I probably would have made my mg bigger on purpose and my normal force smaller on. So it, again, catches my eye. What's my equation? What are they asking me to find? A or Fn? Well, they're asking me to find the scale reading. So what are they asking me to find? Swappy dance. What's M? Oh, gonna go work for Verizon now, are we? I got you. How do you know it can't be? First of all, 720 kilograms, that person's going to have trouble fitting in an elevator. That's a very heavy, that's well over 1,000 pounds. Okay? Wait a minute. Ready? I'm going to ask you almost the same question. What's mg exactly as a number? No, that's an acceleration. What's mg exactly as a number? 720. That's mg. That's what I gave you. So I would be lazy and I would actually just say, you know what? It's that. Minus, and in fact, I'd be so lazy, right? No, you said, I said, what's mg? Did you say 720? I'm sorry, I misheard you then. Okay? I thought I heard you say 9.8.
Oh, no.
Oh, okay. And then I'm lazy enough that I might even go like this. 720 divided by 9.8, that's m, times 4.3. I might not even bother calculating the mass elsewhere. I might just say, oh, for Pete's sakes, I'll just type it in as an equation because I'd have to do that no matter what. What do you get? See, the problem is if I go 720 divided by 9.8, that's a yucky decimal. And so if I, 73.4, I'm rounding off. My answer is going to be off by a tiny bit. I mean, there's a 9 there, so maybe going 73.47 would be pretty good. I would probably just continually, for m, I would probably just type in 720 divided by 9.8 every time I needed an m. It's a little bit of extra typing, but it'd be great. Anyways, 720 minus 720 divided by 9.8 times 4.3, and I get 404. What if I said good, there is a part B. Sorry. 404 newtons. What if I asked for the scale reading in kilograms, but not in newtons? How do I convert newtons into kilograms, at least here on the Earth? Divided by 9.8. So if it was an actual scale, not a physics scale, but a standard bathroom scale, it would read 41.2. Fn divided by 9.8, which was 41.2 kilograms. Mr. Dewick, yeah. Does that mean I could jump higher? Yes. Because you would be jumping with a body that felt as though it had a mass of 41.2 kilograms. You would feel lighter. Now remember, that's while you're accelerating. Real elevators don't accelerate for very long, and they don't accelerate this big. Real elevators, even if you've ever been on a really fast express elevator, it hits a constant speed after about a half second. And now you're no longer accelerating. But there is a chance, hypothetically, somewhere, that I may have been in Las Vegas somewhere on a very fast elevator by myself somewhere, and there is a chance that maybe an unknown physics teacher might have pressed the emergency stop button and jumped right when that was happening just to see what it would be like, and it was interesting. Sorry, hypothetically, it might have been interesting. Hypothetically. And then many body problems. There's going to be an Atwood machine on your test, and there's going to be a mass hanging over a cliff like that on your test. And typically it's going to be find the acceleration and find the tension, or maybe I'll just ask you to find the tension. You're going to need to find the acceleration first. So here's an Atwood machine. Let's make, just for giggles and to annoy you, I'm going to make the mass that looks larger lighter. Maybe this is lead and this is wood. So read the numbers, don't just go by the shapes. I'm terrible at graphics, and so I'm stealing clip art from the internet, is what I typically do. Okay. What does it want me to find, Sarah? What am I going to find first? Find the acceleration of everything, write an equation for everything, and then to find an individual force, look at an individual mass. This is a job. Oh, did they give me a picture? Free body diagram on the picture. What are the forces, Sarah, acting on the 5? Get the obvious one. Is there more than one mass? I'm going to call it M1G. Keep going. Yep. Who's winning? The heavier mass. So what we're really saying is anything that ends up pointing down once it gets to the right-hand side will be winner plus. Anything that ends up pointing up once it gets to the right-hand side will be loser minus. What's my equation, Sarah? Equals. Come on, you know you want to. What? Just me? Really? Wow. Sarah, I demand that you stretch. Come on, you need to stretch. Go ahead. Why are we relaxing, you and I, Sarah? Oh, we're losing tension. This is like spa treatment.
What's the point of writing?
First of all, to make sure you're not missing anything, because for more complicated stuff, especially in Physics 12, it's a good systematic way to make sure I didn't miss anything. Secondly, it does make me giggle a bit, but to have you actually stretch in the middle of a question on a test, I don't think that can hurt. Maybe that might help and relax, because some of you people get really uptight over tests, so I'm trying to give you some strategies. Yeah, mostly for the joke. Yeah. What are we trying to find? So built-in error check. If I cut the rope, what's the maximum the acceleration could possibly be in free fall? And this 5 is slowing it down, so I'm going to get an answer less than 9.8. Tricks of the trade. I think I might have mentioned this yesterday. If instead of 5 kilograms, if this was 11 kilograms and this is 12, I would say, you know what? They're nearly balanced. I'm going to get a really small acceleration. If this was 120 kilograms and 5 kilograms, I would say, this is barely doing a thing. This is going to be really close to 9.8. It's almost in free fall. You can survive just fine without that, but I always try and give you a way you can spot a calculator typo, right? 12 times 9.8 minus 5 times 9.8 all over 12 plus 5. Silly mistakes people look up, do this for MO. And I don't know why, because if I ask you to, if you have $5 and you have $10, what's all your money? I don't think you have 50. I think you have 15. So don't do that. Dividing by 17, I can't do that in my head. No trick for that. Well, there is, but it's yucky. I got 4.04, I guess, if I round off properly. Make sure I didn't make a typo. I think I'm right. I'm going to write 4.04, but I'm going to store this on my calculator. You'll notice that was kind of 1, 2, 3 steps. I would probably make this worth two, maybe 3, maybe even 4 marks, because it's a multi-step question. And we're not even done. What does this question actually want me to find? Which mass would you like to use to find tension, Sarah? To find an individual force, look at an individual mass. Which one? M2? So I'm going to pretend that that mass there doesn't exist. Write me an equation just for this one. Who's winning? Why not M all A? We're writing an equation for an individual mass to find an individual force. Yep. How would I get the T by itself? Can you see I might have chosen this one because the tension is the winner and it's slightly easier to get the T by itself, but not significantly, so I don't care. Swappy dance, yes? T is going to be M2G minus M2A. Because I'm running out of room, I'm going to go straight to my calculator. 12 times 9.8 minus 12 times, answer button. And I get a tension of 69.2. Example, whatever, I didn't bother numbering these. So here's a mass hanging over a cliff. Let's make this mass here, I don't know, 25 kilograms. Let's make this mass here 30 kilograms. Mr. Dewick, doesn't this have to be heavier to pull it over the cliff? No, because what's holding this back? Friction. So this has to be bigger than friction to pull it over the cliff. Let's put a mu. Let's go mu equals 0.4. Find the acceleration. Any thoughts on how I might want to start out? What are the forces acting on the 25? Get the obvious one. Is there more than one mass? M1. Normal force? No. What about here? M2G. I'll call it normal force number 2 to go with mass number 2. Definitely tension. By the way, the reason those two tensions are a consequence of Newton's third forces come in pairs. See the opposite pairs there? Is there friction? Which way? And I'll call it friction force 2 to go with mass number 2. What's my equation? Is there any way that this inanimate box is crawling sideways, lifting this up? No. So if we're accelerating, now it's possible friction could be so big that this is at rest. I would find that out if I got a negative acceleration when I got the A by itself. But for now, I think anything that ends up pointing down once it gets to the left is going to be winner plus. And again, I'm going to walk along the rope. What does that mean? It means M2G and F normal force aren't going to show up in my original equation. It might show up later, but my original equation is going to be winner. Yes, Jaden. Minus friction force number 2, and that equals M all A. Don't you kind of want to just like stretch it out a little bit? Okay. Fine. How would I get the A by itself? I'll often do it on that line because... So, let's see. It's going to be M1G minus friction is mu times the normal, I don't know the normal force. Oh, but look, another force the same size as the normal force. Yeah. Were there any extra vertical forces? I'm not going to this year, but probably Physics 12, I would have no problem giving you an extra force pushing down or an extra force pushing up and saying, oh, by the way, you got to calculate normal force number 2. I can't even say that makes it tougher as much as it makes it longer. Yeah. Yeah. So I'm just going to go mu M2G all over M1 plus M2. Normally, I would write out my numbers next, but I'm running out of room and I'm trying to keep this all on one screen for you. So I'm going to be a little bit bad and go straight to my calculator. On a test, I would still write it out. It's going to be 25 times 9.8 minus, what was mu? I don't know what's mu with you. 0.4 times 30 times 9.8, close bracket, divided by 25 plus 30, close bracket. And I get an acceleration of, oh, the built-in error check, if I cut the rope, I knew the answer was going to be less than 9.8. I get 2.32 meters per second squared. 1, 2, 3, and I didn't write out the numbers. I would probably make this worth 4 marks. 1 mark for the equation, 1 mark for substituting the friction properly, 1 mark for the numbers, and 1 mark for the answer.
So on a test, you write down like all those.
Yes.
Stuff.
Yeah. Because you never know if you haven't accidentally made a silly mistake, and it lets me figure out what you did and give you all the marks that you're, right? As an example, I've seen things like kids mix these two masses up just by copying them down wrong. If I caught that, I'd probably give you, if this was a total of 7 marks, 4 marks for part A, 3 marks for part B, I'd probably give you a 6 out of 7 because I know what you did. But if I don't see that, all I see is, that's a nonsense answer. That's a nonsense answer. I don't know how you got those. Can't help you. Yeah. Shortcuts in homework, never shortcuts on quizzes and tests. And in fact, I think I've told you, I'll even do 3 plus 2 on my calculator on a test, even though I know it's 5. I've written a 6 so many dumb times because my brain multiplied, even though I thought add. I never take risks on a test. I'll show off in my homework and in the lessons with you guys, but on a test, it's all humble. Find the tension Which mass would be way easier to use? Yeah, you can get it with the other one. Go ahead, but I'm going to use 25. Who's winning? M1's not the force. Who's losing? Tension equals M1A, individual force, individual mass. Swappy dance. So it's going to be 25 times 9.8 minus 25 times answer button. 25 kilograms is big-ish. It should be a fairly big tension. Yeah, okay, there you go. 187 newtons. Is that all right? That's pretty much what you're going to see on the test. Now, as a bonus, I might give you a missing mass question. So we'll do a quick missing mass question, and then I'll take any questions you have or want me to talk about. So as a missing mass question, I might say something like this. M1 equals, 40 kilograms. If M1 equals 40 kilograms and is accelerating up, and accelerating up, better yet, at 3.6 meters per second squared. I think I got this hotkeyed. Let me see. There we go. Find M2. Let's get it all on one screen. Did it fit? Hey, it did. Oh, and I guess I should clue in that's M2. By the way, free body diagram, first of all. What are the forces acting on M1? Get the obvious one. Okay. Tension. M2G, tension. Somebody asked, why can't we just do M all? Well, if I try that, if I write an equation for everything, I'll go M2G. Yes, the tensions would cancel. I won't even bother writing those. Minus M1G equals M all A. This is a yucky one to try and get the M2 by itself. You can, but there's an M2. There's also an M2 hidden inside of there that's going to end up on the... It's a lot easier to do one mass and then walk over to the other one. So which mass do we know? M1. Which way is M1 accelerating? Who's winning? Right? Right? Who's losing? M1G, that equals M1A. Why is that handy? They gave me A, I can find T. Or I could have given you the tension, find A. Here, T is going to be M1A plus M1G. M1 was 40 times 3.6 plus 40 times 9.8. And I get a tension of pretty big 536 newtons. Since M1 is accelerating up, M2 is going to be bigger than 40. I can tell you that. How will I find M2? Jaden, which way is M2? If M1 is accelerating up, which way is M2 accelerating? Who's winning? Yes. Who's losing? Yes. What's that going to equal? Which M? This time M2A, because we're writing an equation just for M2. And I want to find M2. How many M2s do I have? How many would I prefer? Let's get them to the same side. I'm going to do swappy dance. That's going to give me M2G minus M2A equals tension. And Ronan, this was something I showed them last day as a very, very clever trick that's worth having in your back pocket. How many M2s do I have? How many do I prefer? What was the grade 9 math trick that I could pull out of my back pocket? Do you remember? It turns out I can factor out a greatest common factor, a GCF, because there's an M2 in everything. And if I do that, I'll get M2 bracket G minus A. And now how many M2s do I have? How would I get the M2 by itself? How would I move the bracket over? What's the bracket doing to the M2?
That was that much easier though?
Yeah. How would you get the M2 by itself? How would you move the bracket over? Huh. Done. What would you have done? How would you have got this M2 by itself?
Wait, what?
He blew his mind. I know. First of all, he's a little shocked that Math 9 is still useful. Yes, it is. He's a little shocked that factoring isn't a complete waste of time. Turns out it's useful.
What were we trying to figure out in the question?
M2. This is what we call the missing mass question, where I give you one mass and make you figure out.
I thought we were trying to find the tension.
Nope, we already did.
Okay.
So it's going to be,
Oh.
was it 536 even? Hey, yeah, it was. 536 even divided by 9.8 minus 3.6.
How do you find the tension if you don't have two masses?
So I'll walk you through it now that you're paying attention, but let me write my answer.
That's
86.5 kilograms. Here's what you do. Since you don't have two masses, look up. Ignore this one. Just write an equation for the mass that you know. And that's why I have to tell you which way the mass is accelerating. I told you it's accelerating up. So the equation for the mass that I know would be winner minus loser equals M1A.
It's not exactly like that. It's one where it's like a card.
It's going to be the same kind of setup, though. You'll write an equation for the one that you know, and I've given you enough information that you could find tension and acceleration from that one, and then you walk over to the mass that you don't know, and since you know tension and acceleration, you can find the missing mass. You'll often have two of them, get them to the same side, factor it out, way nicer. My angels, that's pretty much what you're going to see on the written section of the test with a few hints about multiple choice. No big surprises. No three-mass question. There used to be a bonus three-mass question, but I've already told you your bonus is going to be a missing mass question. We did one, I think we did one in the homework where there was, or in the lesson where there was three masses. If you can do two masses, you can handle 10 masses. It's just going to be a more complicated free body diagram and who's winning, who's losing, lots of winners and losers and winners and losers. Any other specific questions that you're wondering about? Okay, I'm going to pause the video for a second.